Yes, mic works, so you should hear recording all the way through. If you check the videos, we should be good to go. It says limit as x goes to a of f of x plus g of x. So for example, suppose you had the limit as x goes to 1 of x squared plus 3x. Okay? Suppose that that was the limit. You could break the limit up into two parts. That would be the same as the limit as x goes to 1 of x squared plus the limit as x goes to 1 of 3x. You could take a limit of, say, a polynomial or something like that, two functions that are added together, and you could split it up into two pieces. Nope, not at all. You've done it before. Last year we did addition of functions. We broke them up the same way. So if you notice, if you plug 1 in here, what do you get? What do you get if you plug 1 in here? You get 4. Now notice if you break it apart, you get 1 plus 3, which is still 4. So you can break it up into two pieces. Okay? Now, I don't want to write that down for every single thing. You get my point? Like, that's just a lot of writing. So this subtraction, it continues for subtraction, same way. If you were to have a subtraction sign there, it continues the same way. All right? Suppose you had a constant multiplying the function. Let's say the limit as x goes to 1 of 5x squared. What do you get if you plug in 1 in that situation? You get 5. Is everybody okay with that? So you could also write that as 5 times the limit as x goes to 1 of x squared. You could pull a constant out front. You're just fine to do that. Okay? Sometimes that's helpful, sometimes it's not. Here you have multiplication, so you can use your multiplication just like the addition and subtraction. Here you have division, so you could go ahead and use division just like the addition and subtraction and multiplication. Here you have it raised to a power, so you could take the limit as x goes to a value of the function, and then whatever you get, you can take that whole thing to a power. It'll work out the same way. You're really not going to, you're going to use these all the time, and you're not even going to know you're using them. They're so intuitive, you're going to be like, you're just going to do it, okay? You're just going to do it. It's no big deal. But these other ones, we got to think about just a little bit. So this is where people get a little bit confused. Okay, so limit as x goes to a of a constant. Limit as x goes to, we'll say 2 of the number 3. Let's try to understand what the heck that is asking. Okay, so check out my graph. What does the function 3 look like? Good. A horizontal line that passes through 3. 1, 2, 3. One and 2. Does everybody agree that this is the graph of 3? So as x approaches 2, what is the height of the function approach? 3. So the limit as x approaches something of a constant is always just going to be the constant. Agreed? So that's what this one means right here. So the limit as x goes to a of a constant is the constant. Look at the next one. Limit as x goes to a of x. Let's think about what that graph looks like. What does the graph of x look like? Y equals x. Good. Patty's got it. He says it looks like this. Agreed? Okay. So, Patty, pick a number. Limit as x approaches 2 of x. So, anybody know what the height of the function is at 2? It is 2. So as x approaches 2 from the left, as x approaches 2 from the right, it's going to be 2. So the limit as x approaches, say, a is always going to be just a. Very good. So whatever we're approaching, that's what you plug in, you'd get a in that situation. And really, in most situations, you can simply just plug the value in. So this would be a to the nth power. There's a lot of functions where you can just plug it in and the world is beautiful, okay? So limit as x goes to a of the nth root of x, you're going to get the nth root of a. That's amazing. Okay, let's look here. Direct substitution for a polynomial or rational function. If the limit as x goes to a of the function is going to be equal to f of a. In most situations, you can simply just plug a in and you're going to get a result. And we'll practice that in a little bit. Right now, we're going to practice our laws of limits. We're going to make them super simple. Okay? It says limit as x approaches a of f of x plus g of x given this limit is 6, this limit is -2, and this limit is 0. Anybody want to guess how I determine the limit as x goes to a of f plus g? Very good. The limit as x goes to a of f is 6 plus, and the limit as x goes to a of g is -2. And I get 4. Very good. For the next one, switch it. Do h divided by f. You try h divided by f on your own. Go. I've got 0 divided by 6, which is 0. Are we good? Okay, the next one. Shh, don't freak out about it. It says the limit as x goes to a of this. Okay? So what we could really do, I'll show you the long way. You could say limit as x goes to a of -3 g of x plus the limit as x goes to a of 5. Like you could manually break it up like that. And then you could pull the -3 out front. Say -3 times the limit as x goes to a of g of x plus the limit as x goes to a of 5. Do you want to do all that work? So let's just go ahead and let's just plug it in. What's the limit for g? -2. So you plug in -2. We get -3 times -2 is 6 plus 5 is 11. Do d on your own. Go. Yes, that's h times g. I got 6. Are we good? Yeah. Good. Flip it over. Okay, now we're going to do it graphically. It says the graphs of f and g are given. Use them to evaluate the limit if it exists. You will see a common connection in this class. We'll look at graphs, we'll look at tables, we'll look at the algebra. Those are the 3 we have to be able to see. The limit as x goes to 1 of f times g. So let's first identify the limit as x goes to 1 for f. I'm going to approach 1. I have to approach from the left, and what value am I approaching? From the right. So does the limit exist? So it's going to be 3 times, and now I have to approach 1. I'm going to approach 1 from the left. Anybody? -1 and 1 from the right. -1. So I have 3 times -1 is -3. So that's that limit, okay? Now, if you can't see an exact value, go ahead and estimate. Try letter B on your own. Estimate if you can't come up with an exact value, okay? Try B on your own. Yes.
How you're finding which graph you want. So you said -1.
So I'm approaching +1.
Oh, +1. Okay.
So as I approach a value of +1 from the left, the height is approaching -1.
Okay.
As I approach this way, the height is -1.
Oh, I get it. And then same.
Yep.
It was 1. Okay.
So you're going to 3, 3. Better? Okay, I got 11. Is that what you guys got? Okay, shh. Okay, Ella, please ask the question. Yes. Okay, Maddie, please ask the question.
Okay, I was confused on how we're finding zeros. I thought it had to be exact.
Good. It doesn't, so we're going to let x approach 0. So I'm going to look at f here. Is x approaches 0, okay, I'm approaching an x value of 0. What's the height approaching? 2.5. You're just estimating in this situation. Okay? And then now Ella, so we're going to approach 0 for g. So 0 is right here, so I've got that, so I'm going to say -2. Folks, just to prepare us, I know that we do like to come out with integer values, but on the AP exam, there's a lot of answers. We actually round to the nearest 3 decimal places. And so those are the kind of numbers we have to get used to working with a lot. Okay? Won't all be integers. Okay? All right, we move on down. I got the limit as x goes to 2 of g of x divided by f of x. Let's do the limit as x goes to 2. We'll start there. I have to approach from the left. What's that limit? 0. And I have to approach from the right. Does that ever narrow in on exactly one value? No. See how that's the barcode function? So the limit from the left is 0. The limit from the right is does not exist. Do you agree that those two are not the same? So as soon as it does not exist comes up for any part, then the limit as a whole does not exist. Please try letter D on your own. Try something. Try anything. Even if you are like, I still know how to do this part. Try something. Go. Good. If it's difficult, don't give up. I'm not giving up on you.
Can I still get help?
Yes.
So, was this both before, or is this like...
So you're approaching 5, so that limit would be 4. Yep, so f would be 4.
And then would that mean
What do you plug in for x?
5?
5. Take 15 more seconds.
Coming after school.
That's fine. That's fine. That's fine. Good, excellent. Except it looks like we're approaching not, or yeah, your 4 value there. But x is
5.
5.
Oh.
See how you're plugging 5 in for x? And pause, everybody, okay? Shh. So, function. What is the function value as x approaches 5? Everybody see as x approaches 5, the output is 4. Is everybody good there? So therefore, this becomes 2 times something squared times 4. Now, what is the x value? Not the y value. The x value is 5. It's right there. So 5 squared is 25. Times 2 is 50. Times 4 is 200 is the answer. How'd you do there? Good. Yes. For letter C? So we were approaching 2. And your g function, as you approach 2, from the left, you have 0, and from the right, it's something totally different. So that limit does not exist. Okay, excellent. So we've seen the table representation. We've seen the graphical representation. Now let's go to your favorite part, which is the algebra. This says the limit as x approaches 1 of that function. If it's a polynomial or a rational function, you can just plug it in. So let's plug in 1. What is 1 to the 4th? 1 minus plus 1. And what do you get? And that's it. Yeah. I just plugged 1 in. We all good with that? Okay, please look at the next one. It's a cube root function. Cube roots are fine to plug stuff into. If we plug in 0, what is 0 minus 27? What's the cube root of negative 27? You good with that? Okay, now what do we plug in for x here? And when you plug in 3, what is 3 squared? Minus 9 is 0. And the bottom, 3 minus 3 is? Okay, pause there. Everybody must recognize at this point that we first started plugging in that number and we saw a result of 0 over 0. Prior to this class, if somebody asked you what is 0 divided by 0, you would have said possibly 1 or 0 or infinity or undefined. Can you understand why people would choose those? They are incorrect. We do not know 0 divided by 0. It's what we call an indeterminate value. Fortunately, since you are extremely intelligent, you know how to work through this. It's really quite simple. Watch what happens with the top. What do you notice about x squared minus 9? It factors to what? X minus 3 times x plus 3. What do you notice about the bottom? X minus 3. So what's going to happen? They will cancel out. Shh. So now that we've gotten rid of the x minus 3's, now if we plug in 3 to what remains, what do you get? 6. That's the limit. So in this case, 0 divided by 0 was 6. So anytime somebody asks you 0 divided by 0, this is your first test to see whether or not you're ready for calculus. If somebody says, what's 0 divided by 0, and you give them a definitive response, that is wrong. You say, well, it really depends on the function that we're given. Let's try this one. I plug in 0. What do you get in the top? 0. What do you get in the bottom? 0. Huh. Well, maybe I should just write 6 because that's what the last one was. No, that's like dum-dum math, right? Get out of there. So what do you want to do to the top? Take out an x. What are you left with when you take out the x? X minus 5. What do you do to the bottom? And you're left with? 1 minus 4x. Okay, what happens in this situation? The x's cancel. Can I now plug in 0? What do you get in the top? What do you get in the bottom? Positive 1. And so your answer in this case is now negative 5. What do you think about that? You need to be able to handle these limits algebraically. Flip it over. Plug in 0. What happens? Zero minus 2 is? Negative 2 squared is? Minus 4 is? So you get 0 on the top. What do you get in the bottom? Hey, we got to discover what 0 divided by 0 is again. Only elite minds can do that. You guys are elite. Anybody got an idea? Because this doesn't factor. Yeah, let's just square this out and see what happens. What is h minus 2 times h minus 2? H squared minus 4h plus 4 minus 4 divided by h. What happens? The 4's cancel. One of the 8, you can factor on h on top, limit as h goes to 0 of h times h minus 4 over h. So now you say you're going to get rid of those h's. Can I now plug in 0? Yeah. And I get? It is absolutely astounding. If you make up an equation where you get 0 divided by 0, it's incredible how it works itself out nearly every single time. It really is a thing of beauty. H plus 1 cubed. Oh boy. Really? We got to cube it? How do you cube something?
You just
H cubed plus 1?
no.
That's actually how you factor the sum and difference of cubes. It looks like what I have to do is this. H plus 1 times H plus 1 times H plus 1.
So you
So we can do that. Let's just multiply H plus 1 by H plus 1 first. What do you get? H squared. Great. So we're going to take that times H plus 1 then, right? H cubed plus 2H squared plus H. So right now, I was listening to Kendall, and she took all three of these times H, and now she could take all three of those times 1. So you get H squared plus 2H plus 1. Okay, so we just figured out H plus 1 cubed. What's after that? Minus 1 divided by H. Limit as H goes to 0. What happens? Okay, the 1's cancel. And I heard somebody say simplify. Let's say combine like terms. So let's check out some terms that we would like to combine. So I have H cubed plus 3H squared plus 3H all over H. Limit as H goes to 0. Some of you will want to stop writing limit as H goes to 0 because you're like, it's not that big of a deal. Just shared with you earlier, I remember taking my first calculus class in college, and I got all the answers right, and I came back, and the professor docked me points on my test. I'm like, well, he's like, well, you didn't keep your notation all the way through. It's like, but the answer was right? He's like, dude, are you an elite mathematician or not? I said, well, yeah, I'm going to be a math major. He said, you're not cutting it yet. So I'm not really that critical, but I just want you guys to know, okay, you are in calculus. Please, like, continue your notation. Okay, look like you know what you're doing. What can we take out of the top? H. So I have the limit as H goes to 0 of H times H squared plus 3H plus 3, all divided by H. When can you stop writing the limit? You can stop writing it when you actually plug it in. So if we plug in 0 now to the top, what do you get? 3, and that's that. You guys are good. You're doing well. We're going to get a day here where you're going to have time to work in class and ask some questions. We got 3 more to do. Also know I am gone on Monday. I will be preparing for the cross-country race. I'm the person that's managing the course. So I'll be gone doing that. So I got to get to a point where we can start working on something. What I think we might do on Monday is I think I might give you the study guide and ask you to start working on the things that we already know how to do. See what I'm saying? Things that we already know how to do. By the way, this first test generally goes really well. You guys are doing a good job. Just stay the course and trust in the process. And here we go. Letter G, I'm going to show you something new. Let's try plugging in 1. What happens at the top when you plug in 1? How about the bottom?
1 minus 0.
Everybody agree we get 0 as well? That's a problem. And what's interesting about this is you look at it and you say, that doesn't factor, does it? And I'm going to tell you it does. I'm going to show you something really interesting here, okay? I want you to look at that top, 1 minus x, okay? Now, I'm going to switch that. Suppose I had a 1 minus x squared. Does that factor? What do you multiply by itself to get x squared? X, right? So you factor this, you say 1 minus x and 1 plus x. Is everybody okay with that? Watch this trick, because this is what people, they forget this all the time. It works out quite well. You said x times x is x squared, agreed? What do you multiply by itself to get x? What do you multiply by itself to get x? The square root of x, right? Right? Does everybody agree that x times x is x, x times x is x squared? Everybody agree there? Do you all agree that the square root of x times the square root of x is x? So therefore, this factors to 1 minus the root of x and 1 plus the root of x, doesn't it? And all of a sudden, some of you realize that there's factoring options available that we've never considered. And there is. Ridiculous types of factoring methods. So let's factor this. So on the top, I have 1 minus the root of x times 1 plus the root of x. On the bottom, I have 1 minus the root of x. Is that helpful? It sure is. In fact, you can see that the 1 minus the root of x goes away. Can you now plug in 1? And what do you get? 2. We had 2 more problems. We're skipping letter I. We're going to do H and J, and we're done for the day. Any idea what to do with letter H? Let's start by plugging in 0. Love your idea. Okay, so I'm hearing a couple things. First of all, try plugging in 0. What is 0 plus 9? 9. Square root of 9? Minus 3? So it looks like you do get the 0 over 0, right? So that's a problem. So I've heard squaring things, and that's a great idea because once you square it, then the square will go away. But when we square things, we square both sides of an equation sign. Do you see an equal sign up there? Other than the one I just happened to write on the side. No, there really isn't. So we're going to do something else. And this is another skill that we're trying to just review from last year that you learned. When you don't know how to do math, what do you do instead? Spanish. Very good. What do? We multiply by the conjugate. What is the conjugate of square root of h plus 9 minus 3? Square root of h plus 9 plus 3. So we multiply the top and the bottom by that. The conjugate is simply the same thing. We just changed the value of the ending. Because that over that is just 1. And therefore we maintained equality. Watch how beautiful this works out. The limit as h goes to 0. Let's be careful as we look at this workout. What is the square root of h plus 9 times the square root of h plus 9? H plus 9. Do you remember what happened to the middles when we multiply conjugates? Yeah, watch so you can see them go away. If you take that thing times positive 3, and then that thing times negative 3, do you agree that they would go away? Yeah, so the middles go away, then what is negative 3 times 3? So then we have a minus 9. What? Are you serious? You have plenty to work on. Plenty to work on. See you after school.